Okay, so this is a quick presentation on a fun little project that I did during my holidays, and it combines AI with music. The reason I chose this particular project is because it uses something called few shot learning pipeline. It is a very interesting technique which we will explore in this presentation. That's the goal of this presentation, because it kind of gets rid of things such as heavy amount of training data or a large amount of compute power on your computers. You don't need any of that. You need little amount of data, little amount of time, and you can have some intelligent output from this few shot learning pipeline. I decided to use drums because one of the problem statements for EDM producers, EDM stands for electronic dance music, and EDM producer means someone who creates electronic dance music. So, one of the common problems for EDM producers is that they cannot play drums. Even I cannot play drums. So, I do produce EDM, I produce psychedelic trance music, and even I cannot play drums. So, typically what a EDM producer will do is they will try to click somewhere and they will try to make patterns that they think it sounds good, and they will create their drum parts, or they can even use something like this. So, this is a really nice book called 260 drum machine patterns, and they are filled with a variety of patterns like this. They look like this. So, the producer can just look at these patterns and they will try to feed it in their DAW to create this pattern. So, just to outline how that looks, so here I have a Bitwig project going, and it has this very basic kick and bass loop which sounds like this. Okay. And then what they will do is they will, let's say I want to create a drum loop over here. So, I am creating a MIDI clip, and in this drum loop they will have a few drum sounds like this, and they will randomly click somewhere, or if not randomly they will click in some predetermined positions like they will see in this kind of a book. So, let me do that. So, let us say I click over here, once over here, and if I keep playing that, and it sounds okay. Then another technique is to kind of have a certain style of loops that are common in this kind of music to play along with that. So, if I do that, it sounds something like this. And this is not bad at all, and one can totally go on like this, and that is what people do most of the time. Even I have been doing that. So, I wanted to solve this problem. If I can kind of make this a little bit more intelligent and have some structure to it, then it might sound better. That is the whole idea. So, I am going to remove this, I am going to mute this for a moment, because this also has its own place. These rudimentary patterns, they define the genre. So, that is why they are needed, but this over and above thing that the producers do randomly, that is what I wanted to kind of address. Okay. So, coming back to the presentation now, I will get rid of this file, and yeah, so that is the problem statement, so to speak, and the goal is obviously to create unique drum patterns, because the way I was going on about it, I will end up creating similar patterns for all my tracks, and they will sound the same. You will not be able to distinguish them from one from the other. So, the goal is to obviously create unique drum patterns from text descriptions, because that is pretty much the style today for prompting the AI to do something for you. You give it a query and then it gives you back the answer or something. So, the idea is to create unique drum patterns from text descriptions. The goal also is to support a bunch of styles. So, there is some structure to that drum pattern that is generated, and we will use the styles that are outlined in the book that I was showing, such as funk, jazz, rock, afro-cuban, etc. So, the good news about this is that exact book, right, I found a representation of this on GitHub from this guy Stephen Handley. He had outlined that same book, Drum Machine Patterns 260, into a JSON file like this. So, this is that JSON file. It is pretty big, as you can see, it is over 20,000 lines. So, I used this JSON file to act as my raw data for the training pipeline, and we will get into that shortly. But basically I found that drum machine patterns 260 book like this in a JSON format, which was very convenient. So that's that. I'm going to close this and go back to my presentation. So it's going to have these multiple styles from that book. I also wanted to have some speed variations, like it should not be the same loop speed each time. I should be able to cut the speed by half or double it or leave it normal, whichever way you look at it. And finally, I wanted to export as MIDI files so that I can seamlessly integrate it in my DAW. So these were my goals, and the example prompts look like this. So this is just stuff that I've made up over here to include some of those categories like funk, jazz, rock, etc. So something like create a funky half-time groove with ghost notes. So this kind of an input should output a MIDI drum pattern that has something to do with funk, is half-time, has a groove, and does have ghost notes. And we'll see all this in a demo that is part of this presentation. Or generate a jazz shuffle with afro-cuban influence. So these kind of inputs should more or less try to put together a drum pattern that has these kind of jazz or afro-cuban influences if the prompt includes those keywords. There are some nuances around this which we will get into later, but this is the interface that I am looking at for this particular project. So let's come to few shot learning. Few shot learning versus traditional learning. What is the difference between them and why I chose few shot learning in this case? So few shot learning by design does not require too much of data. For example, in this case, I am using the GitHub JSON file that I showed, which had only 1331 examples. Traditional training would need 10,000 plus examples or even more. So data requirements drastically come down, just 1,000 examples for few shot learning. Compute power. I was able to do this with my regular personal computer because first of all I am using Ollama, which we will get into shortly. I have been playing with Ollama and some of these models of Ollama, right? And Ollama is tuned to run on your consumer, the consumer grade operating computer that you have. It's tuned for that. I could have totally used Hugging Face or something else, and I will as time goes by. But for this particular project, I stuck to Ollama because of the ease of use it offers. So compute power was within my limits. I didn't have to invest into another machine or buy some compute power elsewhere or whatever. I could get by with my own computer. Whereas traditional training would have required a high-end GPU, 24 GB plus, which is way outside my current budget for this particular project. But basically, it would have required a lot of compute power for traditional training. Training time, that also goes down. There is no training time at all required for few shot learning, and we will see that once we walk over how this few shot learning takes place. But traditional learning takes hours and days of training. In fact, it can even take months. I have a agenda for using Hugging Face later on, and it involves about 6 to 7 months of training. So that's another criteria. I wanted less training time. So that's what few shot learning also offers. No training needed at all. Model size. I'm using an existing LLM because I'm not doing any training, which means whatever model I get from Ollama from over here, I use it as is. I do not change its weights. I do not train it per se. I don't change it. I just use it as is. But when it comes to traditional training, you need to take an existing model, and on top of that you need to train it so that this model weights and everything within it changes, and now you have this new custom model that you're going to use, and you need to host that somewhere too, which you can obviously host on Hugging Face. But the point is I wanted to just get by with existing models, no training, nothing. So model size also kind of gets limited to an existing LLM. There are some drawbacks also of this, but to get started quickly, this is enough. Flexibility. I can easily add new styles because there is no training required. So I can it's just a matter of updating a JSON file for me. In this case, I'll have to retrain the model for traditional training. And lastly, iteration speed. I can instantly make the changes whenever I want. Here, this process is a little bit, the workflow is a little bit demanding, hence iteration is a little slower. It has its own merits, but for a quick start, for a POC level kind of a product, I felt that few shot learning is a great way to go about it. And let's look at how it works. So this is how the system looks. The overview looks like this. This user input starts with the user input obviously. So let's say my user input is create funk beat. So I inputted this to my project. It went into this few shot learning mode. Basically what it does is it has let me show that over here. This is my training data. It's a JSON file constructed from the JSON file that I was showing you earlier from GitHub. It has these variety of inputs. So this is one input. It has some metadata over here, and at the same time it has a sample string. For example, this one says generate a heavy rock beat, and then it has a sample output for that, and it has some metadata for it. So it doesn't mean that the user has to enter exactly this. It's just that this kind of a sample data helps the LLM to kind of perform a basic search across this training data, so that it can come up with some outputs. And that's exactly what happens over here in this few shot learning step. It goes and finds relevant samples from the training data, and the search is basic. It is that is its drawback, but at the same time it lets us move ahead in this project without having to invest too much of time or money. So it just goes ahead in this case through all of this training data based on whatever input you give, and identifies 3 top examples from this data. That's what it does. Once it gets those 3 top data from the training data, it passes it over to the model. I am using Llama 3.1 in this case, but you could use anything else. So basically it passes on those 3 examples to the model. The model now has these 3 examples as its context. Using that context, it kind of analyzes that context and comes up with its own patterns. Since it is a AI model, it knows how to look at the relevant examples and find some patterns out of it and generate new patterns based on those patterns. So it is not randomly generating some pattern. It is using an existing pattern which we have obtained from this training data, and it uses that to generate the pattern. Finally, it creates a MIDI file, and then that MIDI file is something that you pull inside your DAW and use it in your track. So that's the system overview for how few shot learning takes place. Now you might notice that this is similar to RAG. So RAG is something that you may have read about or heard about in a variety of contexts when it comes to AI, and it might be good to kind of go over that too a little bit. RAG stands for Retrieval Augmented Generation. What it means is it lets you send something to the LLM, like ask a question or whatever, and instead of having the training data like this stored in a JSON file, it will let you pull that additional information by making some API calls or querying your database or whatever it is. So it lets the LLM go and look for additional information before it answers you. So that's the retrieval aspect of it. Once it gets that, it uses whatever it found out as the context and uses that context to generate the final answer. So there's retrieval, augment whatever what the model retrieved, and generate the answer. So that's retrieval augmented generation. So that's what it looks like. This flow is somewhat similar in the sense here it does not make any API calls or does not query a vector store, but it does query this JSON data where it tries to find relevant examples from that training data. So in a manner of speaking, it is somewhat similar to RAG, but it is not exactly RAG. I wanted to call that out because this is a good segue into getting into RAG based flows. I have called this project PyDrums because it is primarily in Python and it is about generating drum patterns. So let us look at some examples on how this works. And I do have my DAW open over here. And this is a finder window where all the MIDI output will be seen. So the way to use PyDrums is, and it is an open source repository, if you want, you can just clone it from my GitHub and you can use it. Make sure that you install the requirements and then you invoke it by calling the PyDrums CLI. PyDrums generate -d, d stands for description, and here you give your input. So So let's say the input that I want to give here is, I'll keep something simple for now, create a afro beat, okay, and if I hit enter, it is going to generate something similar to what this particular query is, and it is going to put this file, is going to create this MIDI file which has the name based on the input itself. So create a afrobeat became the name of the MIDI file, and now what I need to do is I have to just drag it to my DAW, and you can see that this is what it has generated. So if I can just loop this part, and if you want to hear it, this is how it sounds like. Okay, I am going to run the same command again, because I want to show you that just because you enter the same prompt again, it does not mean that PyDrums is going to generate the same pattern again. This is very important. So producers, what they do is they will have some plugins for generating these drums, and those plugins have a variety of samples, a variety of patterns already predetermined. The problem with that is that each time you use a particular sample or a pattern, it is always the same. So with this, because there is AI on the back end, and it is trying to generate new patterns each time based on your prompts, it does not generate the same pattern again and again. So I am going to execute the same command, same query, and now it has generated this MIDI file, which I am going to drag again over here, and as you can see, it has generated it slightly different. Okay, and I can keep doing this, keep giving it the same command and expect to have a completely different output for it. And this is the last we will do in this segment. See, it sounds completely different, but it follows the same prompt that you had given. And then you can obviously have different kinds of commands as well, where you combine things. So let's say I do something like PyDrums generate -d for description, and the prompt will be create a create a funk beat with jazz influence. So now I just made something up and I typed it, and it has created this file. What it does is it just performs a basic search across our training data, looks for 3 patterns that kind of match this description and hands it over to the model. Model generates a pattern, a new pattern based on that description and those 3 examples that you provide to the model. If I drag that in over here, this is how it sounds. And then needless to say, you can always combine it with the traditional way of doing these things by having the the genre defining parts of the of the drum parts, like this, for example these open hats. And now one more thing I want to kind of showcase is I'll keep the same prompt, but I'll also add the word halftime. What it means is it is going to generate a new pattern, but it is going to slow down its speed. So if I pull this in now instead, this is how it sounds. And if I generate it again, maybe try it differently this time. Instead of jazz, we will say tango influence, and drag that in. Needless to say, you can have different drum sounds as well. You are not limited to the ones that you had originally. So I have another drum kit over here. I'll enable that and play the same thing again. Okay, so I hope you get the picture, and maybe I'll just place some chords behind it so that it sounds a little nice. Okay, so that wraps up the demo. Now I want to cover what are the next steps for this project. So the next steps are obviously to move beyond few shot learning. While I like few shot learning and it lets me quickly put together this project, I don't want to limit it to few shot learning. What I want to do is I want to move on to the next phase, which is basically use a smaller model, maybe like something that has got 80 million parameters. I was using Llama 3.1 with the 8 billion parameters for this particular project, but I am planning to go for a smaller model and perform training on top of that. It will take some time, and to make it production ready it might even take a year, but the point is I want to make a model that is already a drummer. So at the moment what it is doing is it is using a base model which has nothing to do with drums, and it's just that it is giving it some context, and using that context the model is creating these patterns. So what I want to do is I want to create a model which understands drums intrinsically, and for that training is definitely needed. And then if I kind of try to combine it with the RAG flow, just to quickly cover that, what I want to do is the RAG flow, the retrieval augmented generation flow, it requires a vector store, and that brings us to something called embeddings. What that means is if you have a text like this, and I am taking a very generic example here, it has got nothing to do with drums. Let us say I wanted to query something like show me the churn rate by region, something like this. So what embedding means is it converts that text or that kind of a prompt into a vector which looks like this, which is an array of numbers, and it stores it. This is called an embedding. So the reason for this is if you store your data like this as opposed to the way I have it over here, which is basically each prompt has a sample output, and this is all string information, there is no vectors are involved. But if I store it as vectors, what that means is now the model can perform a semantic search, and it is much faster to do these kind of things. When we do a vector store, when we put a vector store behind it, you can perform semantic searches which are very fast. So that's what I want to go into next for this particular project. So what it will mean is that I have this raw data right now over here. So this is a representation of that data on the left. Once it's converted to a embedding, it will look like this. So this becomes this, and now once I have most of these stored, and these can also be in a JSON file, or it can be in a vector store DB, it can be in a it can be in a format that is suitable for a vector store. It can perform really fast searches, and those searches are semantic, and you can even have more the retrieval is a little bit more nuanced, it's a bit more relevant. Right now whatever search I am doing, it's very basic, it's just looking for keyword matching and tries to put together a example set based on those keywords. But once it becomes a vector, it will be much more faster. So that's the next steps for this project, and yeah, that's about it. And I want to leave you with a thought: AI will not take your job, it will only tickle you silly with stuff it will let you do single handedly. So there is nothing to get scared about AI, it's something that's very remarkable, and I encourage you to get into more and build some product that helps you in your own hobbies or whatever. So yeah, so that's it from me. Hope you enjoyed this presentation. Cheers.